Hello everyone. I've made something that is stupid and hackish enough that I figured I should share it. I've been doing a lot of reading and watching videos about very archaic computer systems recently, like paper tape drives and some of the other stuff back from the very early era, and I'm kind of fascinated by it. So I wanted to try to, with my limited resources, replicate something like that just for fun. Of course, because of the limitations of what I'm using, the scale is ridiculously useless. But here we go anyway. So the idea is having a drum that has bits stored on it physically that is read by interrupting a beam of light between an LED and a sensor. Obviously, you wouldn't have had an LED in that period. But basically this came from me wanting to do something with punch cards, but me not having, at the time, a good hole punch, so I decided to do something else. Let me just get this powered on. And I've got two independent power systems. I've got a USB thing that's driving the Arduino, and then I've just got a set of batteries driving the actual motors or whatnot, because otherwise the motors have a tendency to brown out the Arduino. Okay, so what we have here is fairly simple and fairly simple, basic, and stupid. Here we got a control board. I figured it made more sense to have a board just to deal with the drum drive connected by a ribbon cable with the few wires that we actually needed, so that I could have the Arduino, the power system, and the controls on a separate board. Oh yes, and You are in fact, your eyes are not lying to you. That is in fact a paperclip soldered to, that's actually the H-bridge motor driver, because that makes a really good heatsink actually. So we've got a couple different features. One is just this stepper motor that rotates the drum. Then we have got a servo that drives. Let me just zoom in a little bit. Got a servo that drives the reed head back and forth. Now, and I can position it. I'm just doing this manually right now. If I bother to finish this, I'll eventually write some software for it. I may or may not finish this project because I've got the proof of concept. Let's see, what was I going to say next? Oh, so I've got a servo that lets me position this. Yes. This is a rubber band that actually, I initially used that because the strip of leather I was going to use as the drive belt wasn't long enough, but it turned out that using a rubber band also means I don't need to have a tensioning wheel, because the rubber band itself does the tensioning. And of course you can adjust the tension to be tighter by the very sophisticated method of tying a little knot in it with something to hold it in place. This is very high-tech, people. Okay, so this reed head here is fairly simple. It's basically just an LED and a photoresistor, so I can basically have things interrupt the beam. And you can see, as you can see, I've got something here that recognizes when the beam is interrupted. It recognizes that as a bit. That's actually not just because of a completed circuit. That actually the data from here and the signal for that are both being set by shift registers, or set or read by shift registers. So that's all being software controlled. Okay, so what we've got here, let's turn it around. What we've got here is fairly simple. The drum turns, and the black one is marking the home position because of how I'm doing this. I needed to have a home position where it was safe for the reed head to move back and forth. And then these little notches here are basically just the physical bits that they go through and they disrupt. They go through and they disrupt the beam. Now, because it's not enclosed, so because I want you to be able to see it, it does mean that photoresistor is picking up ambient light. So I need to lower the light to eliminate the sunlight. And if I zoom out a little bit, this represents when it's reading a bit. And as you can see, it can recognize when it's reading bits. I can stop, then I can move to a different track. I've only got the 2 tracks here. then go through here and proceed to read the bits off of that. If I bother to finish this design and write software to control it and everything, I've got, basically I can have 7 bits per track, and I've got room for maybe 4 tracks. So that's, so that's basically, I can have 4 7-bit words. So this may be the most useless storage device ever made, but I've enjoyed all the challenges of getting it together, and I've learned a fair amount, and I may finish it, I may scrap it, to go on to bigger and better things, but in either case, it's an interesting proof of concept of having a mechanical storage device. Whoop. That's not supposed to happen. As you can see, one of the things that I need to have is I need to have a sensor so the drum can actually tell its position, so the read head will only move when it's safe for it to move back and forth. Either way, that is my incredibly stupid little project. Thank you for watching and pretending to be interested. God, this is so stupid.